Okay, so our last time we met, and we're going to use these for these two problems. All right, so let's go and jump into number 6. We have the sequence here, and we have to answer 3 questions about the sequence. Okay, so before I even answer a sequence, the first thing I want to figure out is, do I have arithmetic? All right, or do I have a geometric? Okay, and to figure that out, it's simple. All you have to ask yourself is, how do I get from that one term to the next term? If you're adding or subtracting, it's arithmetic. If you're multiplying or dividing to get to the next term, is geometric. Okay? I'm hoping most of you can look at these numbers, because they're pretty nice numbers, and understand how we're going to the next term. Okay? But I'm going to play devil's advocate, and I'm going to say, you know what? I can't really see how we're going to the next term. Okay? And I want to show you how you can test whether it's arithmetic or geometric. Okay, and this is a good tool to have just in case the numbers that you are given in the sequence are not really nice numbers. You might have fractions in here or decimals, and that's going to be really hard to see if it's geometric or arithmetic. Okay, so our goal right now is to figure out how or what am I doing to get to the next term and the next term and the next term. Okay, so I'm going to play dumb and pretend like I don't see that it's really multiplying by 2. Okay? So let's pretend we're going to check if it's arithmetic. And remember, arithmetic uses plus or minus to get to the next term. So to test arithmetic, what you want to do is take 2 consecutive numbers, 2 numbers next to each other. I'm just going to take the first 2 because they're nice. So I'm going to take -6 and -12. And what you're going to do is take the second, in this case, the second term, which is -12, and subtract it from the first term. So minus the first term. And we talked about this before in a previous Zoom. So what this formula gives me, it's second term minus first term. And what it will show me is the number that I'm using to add or subtract to get to the next term. So let's try this out. So we have -12. 2 negatives make a positive, so we have +6. If I do this math, -12, +6. Okay? Based on this formula, it says in order to get to the next term, if it's arithmetic, we are going to be subtracting 6 every time. So let's test that out. Let's test out if we're actually subtracting 6 every time. Okay, so let's check it out. -6 and -6, that gives me -12. So far, so good. -12 and -6, if you do this math, this actually equals -18, which means we're supposed to get -24. That means it's not arithmetic. Okay? So that tells me right off the bat, this is not an arithmetic sequence. I'm not adding or subtracting to get to the next term. So my only other option is to try to figure out if it's geometric. Am I multiplying or dividing something to get to the next term? Okay? So how do I check if it's geometric? It's very similar to this idea. We're going to take 2 consecutive terms. I'm going to take the first 2. And what I'm going to do is take the second one, in this case -12, and I'm going to divide it by the first one, which is -6. Okay? And what this formula does, second divided by first, what it does is it gives me what I should be multiplying if it's geometric. So if you look, this gives me +2. Okay? So I want to check, am I actually multiplying by +2 to get to the next term? times 2, times 2, times 2, times 2. And let's check if this works. So negative 6 times 2, negative 12. Negative 12 times 2, negative 24. And so on, and you'll notice this works. So this tells me that my sequence that I just had is geometric. Okay? And the number that is multiplying, it has a special name if you remember. This is called the common ratio or common multiplier. It has two names. You can use either one. Okay, so common ratio or multiplier. All right, so now that we have all this information here, we know it's geometric, we know what we're multiplying by, we could go ahead and figure the rest out. So we're going to write the explicit formula. So if you look, I've given you the formulas down here that we did last time we met. We know it's geometric, so I'm going to use the geometric formula and I'm going to use the function form. Okay, so we're going to go f of n, and we're looking for the first term. So if you look at our sequence, the first term is negative 6. So equals negative 6. The next thing we write down is, what are we multiplying by? The common ratio or common multiplier? In this case, it's 2. So we're going to go times 2, because we're multiplying. And then the formula calls for us to put an exponent of n minus 1 to my common multiplier. Okay? That's the explicit formula. We are done. So part A is done. Now, once we have this formula, it's really easy to find the 10th term in the sequence. So what we're going to do is, we're going to plug in 10 in for n in our sequence. So let's do it. Okay, and then we just have to remember order of operations says we want to do exponents first before we multiply. So 10 minus 1 is 9. So this is where we're going to start needing our calculator, because we have 2 to the 9th power. So let me get my calculator out. It's like 5 something. So 2. $512. So this is negative 6 times 512, and then we multiply that together. And the 10th term in our sequence is negative 3072. Okay? All right. Last but not least, we want to describe what the graph looks like. So real quick, I'm just going to sketch the graph for you. Okay, and we're going to use the sequence to sketch the graph. All right, remember, the sequence is really our outputs. Okay, so if you really wanted to, you can make points out of this, so you can see what the graph looks like. We already know from previous Zooms that geometric is going to be some type of curve, okay, an exponential curve. So they can look like this, like this, upside down, right side up. It can be any one of these curves, okay? So which one do I have? Very simple. We're going to look at our first number in our sequence, okay? It says, let me adjust my graph so I have a little bit more room. Okay, and I'm just going to sketch. It's not going to be accurate. I just want to see the shape. So if you look at negative 6, this is actually your output or your y value. This is my first term, and it's negative 6. So I'm going to go on the x value, my first term, and I'm going to go down 6. Okay, so think of it this way. It was my first term, and my output was negative 6. That's a real quick sketch. My second term is negative 12. So on my x-axis, I'm going over 2, and I'm going down 12. So 2, negative 12. Okay? And if you continue this pattern, you end up with a curve that looks like this. Sorry. Okay, the curve goes the other way. All right. So it's a bad sketch, but it does this. Okay. And again, you can see that here because by the time you get to the 1, 2, 3, 4, fifth term, so fifth term, you're all the way down to 96. Okay. So that's kind of how you're going to check out this. So when you describe this in sentences, you want to use the rate of change in your description. Okay. Is my rate of change going up or is it going down? So you have a rate of change that's going down. Is it a line graph or is it a curve graph, exponential? Exponential's curve, linear is a line, arithmetic. Okay, so this is all stuff we talked about, but that's how you do number 6. All right, let's go a little faster for number 7. Okay. So on number 7, if you check this out here, we are going to do this guy. We're not going to test it. You should be able to see what's happening here. Okay. As I go from one point to the other, or one term in the sequence to the other, you'll notice that what you're really doing is you're subtracting 7. Okay, so once you figured out you're subtracting 7, because we are subtracting, I know we have an arithmetic sequence. Okay, so when you have an arithmetic sequence, your number that you're adding or subtracting is called a common difference. This is one of your vocabulary words from the test. Okay. All right. So now, because of this, let's write the explicit formula. But now we're going to use the arithmetic formula. So let's start that thing. So it's going to be f of n equal to, and our first term we have is 52. So I'm going to put 52 here. And then we're going to put our common difference, the guy that I'm adding or subtracting. So I'm actually subtracting 7, so minus 7. And then it calls for parentheses and minus 1 with our common difference. So parentheses and minus 1. Okay, so this is actually the explicit formula here. But as I mentioned before, we're going to want to clean this up. Okay, this is not wrong. It's just we want to simplify this. We can now distribute the negative 7. So we're going to do the simplified version. On the test, you might have either one. So be prepared to simplify if you need to. So we're going to distribute the negative 7. So it gives me 52 minus 7 times n plus 7. Okay, and then we're going to combine these like terms. Positive 52 and positive 7. That gives me a positive 59. So it's going to be negative 7 times n plus 59. And this is our cleaned up version or simplified version of our formula. So this and this are the formulas. This one's simplified, this one's not. Okay, on your test, they will give you both. You have to decide which one is the correct answer. Okay, this only works for arithmetic sequences. You cannot simplify a geometric. Okay, can't simplify this. All right, now because of that, let's go ahead and figure out the 25th term. So that means I need to plug in 25 in for n. And I'm going to use the clean version. Okay, so we're going to go f of 25 equals -7 times 25 plus 59. All right, now we're going to go -7 times 25. We get -175 plus 59. And our 25th term in our sequence is -116. Okay, and that makes sense. If you look at a sequence, we're going lower and lower, and eventually we're going to get to the negatives. Okay. All right. Let's go ahead and describe what this graph looks like. So let's sketch it really quick. And again, using this sequence, this is my output or my y value. So it's going to be 1, 52. So if I sketch that 1, 52, we'll put it there. And then the next one is 1, 45. I'm sorry, 2, 45. 2, 45. Think of an input-output table here. The next one is 3, 38. Okay, and we should know that we should be having a line graph because arithmetics make linear graphs. Geometric makes exponential curves. So we know we're going to have this, okay? Those are the two options when we have arithmetic. So we're essentially having this right now. So if you can describe that using rate of change again. So my rate of change is decreasing and is decreasing by 7 each time. Okay? And it's a linear graph, a line graph. All right, guys, that is it. That is the two problems I wanted to show you. I'm going to free you up so you could work on that review. Check out that video. I worked out some problems for you on the review. Hopefully all that helps you to get prepared for tomorrow's test. Okay? If you have any questions, go ahead, stay on the Zoom. I'll be on the Zoom. I'm going to give you that check-in code. Please check in. Don't forget to do that. And then you are dismissed once you check in. Okay? Good luck tomorrow.